Have you ever wondered what would happen if Earth was as dense as a black hole? Imagine for a moment the world as we know it, packed into an object so dense that not even light can escape its gravitational pull. Black holes, these enigmatic entities, have long been a source of fascination and curiosity. They twist and contort the very fabric of space and time, creating phenomena that defy our everyday understanding. Ready to dive into the depths of this cosmic conundrum? Let's begin. Before we delve into the dense matter, let's first understand what a black hole is. Picture an object with a gravitational pull so strong that nothing, not even light, can escape its grasp. This is the essence of a black hole. Born from the remains of a star, when a massive star exhausts its nuclear fuel, it collapses under its own gravity and forms a singularity, an infinitely small and dense point in space. Now, let's talk about the formation of a black hole. The life of a star is a delicate balance of forces. The outward push of energy from nuclear fusion in the star's core is counteracted by the inward pull of gravity due to the star's mass. When the fuel runs out, gravity wins, and the star collapses. If the star is large enough, this collapse leads to a supernova explosion, leaving behind a core so dense that it warps spacetime, creating a black hole. Characteristics of a black hole are as fascinating as its formation. At the center of a black hole lies the singularity, where matter is crushed to infinite density. The laws of physics as we know them cease to function, and spacetime curves infinitely. Surrounding this singularity is the event horizon, a boundary beyond which nothing can escape the black hole's gravitational pull. Now let's focus on the incredible density of a black hole. Imagine all of Earth's mass compressed into a sphere with a diameter of just over ½ an inch. That's how dense a black hole is. To put it another way, a sugar cube-sized amount of black hole material would weigh as much as Mount Everest. That's an astronomical amount of mass, packed into an incredibly small space. So with this understanding of a black hole's density, imagine if Earth shared the same characteristic. Stay tuned as we dive into this cosmic thought experiment in the next segment. If Earth were as dense as a black hole, it would be a dramatically different place. Now, let's dive into the dense depths of this cosmic curiosity. Imagine our home planet, Earth, suddenly compacted to the point where it matches the density of a black hole. Our beloved blue sphere is now a tiny point, smaller than a grain of sand, yet still containing the same mass. Black holes are incredibly dense, so dense in fact that they warp the fabric of space and time itself. By becoming this dense, Earth's gravity would undergo an extreme makeover. It would be so intense that nothing, not even light, could escape its gravitational pull. You might think that this would mean the end of life as we know it. However, the reality is a bit more complex. If you were standing on the surface of this ultra-dense Earth, you wouldn't be squished into a pancake. Instead, you'd experience gravity as you do now, since gravity depends on mass and distance. And those have not changed. But what about the Earth's size? Well, here's where things get really interesting. The ultra-dense Earth would be unimaginably small. As mentioned, it would be less than a grain of sand, a cosmic speck floating in the vastness of space. All of Earth's landmarks, continents, oceans and life forms would be compressed into this tiny point, yet the planet's overall mass would remain the same. We wouldn't have room to exist as we do now, and our world would be fundamentally changed. However, the interesting thing is, we wouldn't necessarily be sucked into the black hole. Instead, we would be in a state of free fall, perpetually falling towards the center, but never reaching it, due to the intense gravitational time dilation. In essence, Earth would become a singularity, a point in space where density becomes infinite, and our understanding of physics breaks down. But the effects wouldn't stop there. The transformation of Earth into a black hole-like entity would have far-reaching implications not just for us, but for the entire universe. Stay tuned to discover the cosmic consequences of this incredible thought experiment. The extreme density of a black hole would have far-reaching effects beyond Earth. To begin to grasp the magnitude of such an event, we need to imagine the solar system as a grand cosmic ballet, with each planet gracefully dancing in its orbit. The sun, the star of the show, holds everything together with its gravitational pull. But what would happen if one of the dancers suddenly gained an immense amount of mass, becoming as dense as a black hole? The gravitational balance of our solar system would be thrown into chaos. The pull from Earth, now a black hole, would dramatically increase, disrupting the orbits of nearby planets. The moon, once our friendly celestial companion, would be the first to be sucked into the abyss, followed by the inner planets, Mercury, Venus, and even Mars. The sun, though massive, would also feel this new gravitational pull. It could even start to wobble, causing other planets to adjust their dance steps, changing the rhythm of the entire solar system. Even faraway outer planets like Jupiter and Saturn could have their orbits perturbed, potentially leading to cosmic collisions. The asteroid belt, a region of space between Mars and Jupiter filled with millions of rocks, would be stirred like a cosmic soup. This could unleash a barrage of asteroids hurtling in all directions, posing a threat to any planet in their path. And it wouldn't just be our solar system that's affected. The increased gravity could reach out into the galaxy, drawing in nearby stars and their planetary systems, causing further celestial chaos. But it's not all destruction and chaos. The birth of a black hole also means the birth of a cosmic laboratory, a place where the laws of physics as we know them break down and where new, unexpected phenomena might be observed. So, while the transformation of Earth into a black hole would undoubtedly be a cataclysmic event, it would also provide a unique window into the fascinating and extreme world of black holes. Indeed, the consequences would be astronomical. As intriguing as this scenario is, it remains firmly in the realm of the theoretical. Let's delve into why an Earth as dense as a black hole scenario is impossible in reality. To comprehend this, we need to understand the basic laws of physics and the nature of matter. Matter, as we know it, exists in different states: solid, liquid, gas, and plasma. Each state has its own distinct properties, and they're all governed by the laws of physics that have been constant since the dawn of the universe. Now consider the phenomenal density of a black hole. It's so dense that it warps the fabric of space-time itself, creating a gravitational pull so strong that not even light can escape. For Earth to reach such a density, it would have to undergo a process called gravitational collapse, where its matter compresses to an almost infinitesimal point, known as a singularity. But here's the catch. Earth, composed primarily of rock and metal, simply doesn't have enough mass to trigger a gravitational collapse. This is a process reserved for celestial bodies of a far grander scale, such as massive stars at the end of their life cycles. Moreover, the Pauli exclusion principle, a fundamental law of quantum mechanics, prevents particles of the same kind from occupying the same quantum state simultaneously. In simpler terms, there's a limit to how much you can compress matter before quantum forces kick in and resist further compression. So, even if we could somehow artificially increase Earth's mass to prompt a gravitational collapse, the laws of quantum mechanics would intervene, preventing Earth from reaching the density of a black hole. In essence, the laws of physics and the nature of matter conspire to make an Earth as dense as a black hole scenario an impossibility in our reality. These laws, which govern everything from the tiniest particles to the grandest galaxies, ensure the stability of the universe as we know it. So, while we can ponder and explore such scenarios, we can rest assured Earth will remain as it is. Our journey into this cosmic thought experiment has been a fascinating one. We've traversed the borderline of reality and fiction, exploring what might occur if our home planet, Earth, was as dense as a black hole. To recap, we first grappled with the enigma of black holes, celestial bodies with a gravitational pull so strong that not even light can escape. We then toyed with the concept of the Earth possessing this same unfathomable density. In this scenario, Earth would shrink to the size of a marble, yet its mass would remain unchanged. This would cause catastrophic cosmic consequences, with the fabric of space-time around Earth warping to the extreme, leading to a deadly gravitational pull. We've also ventured into theoretical possibilities and impossible realities. Here we examined how the laws of physics as we know them would be stretched to their limits and even broken. Time, space, and life as we know it would drastically change, leading us to question our understanding of the universe. In this thought experiment, we've peeked into a world of paradoxes and enigmas, challenging our perception of reality. This exploration of a cosmic what-if scenario is a testament to human curiosity and our endless quest for knowledge. So next time you look up at the night sky, remember, there's always more to ponder in the vast expanse of the cosmos. Ever pondered about life on an Earth twice its size? A fascinating thought, isn't it? Today we'll journey through this hypothetical scenario and explore the intriguing possibilities that come with it. Our first stop is gravity. Gravity on this larger Earth would be significantly stronger. You'd feel heavier and every step would require more effort. Jumping high or running fast would be much more challenging feats. World records for sprinting or high jump, those would be a thing of the past. Now what about our atmosphere? With the increased gravity, the atmosphere would be much denser. This could result in higher oxygen levels, which might lead to the evolution of larger land animals. Imagine walking around with giant insects and bird-sized butterflies. But it's not all larger animals and heavier steps. A larger Earth would have a stronger magnetic field, which would provide better protection against harmful solar radiation. This could potentially lead to longer lifespans and a lower risk of certain types of cancer. However, there's a flip side to this coin. A stronger magnetic field would mean more frequent and more intense geomagnetic storms, which could wreak havoc on our electrical infrastructure. Imagine the chaos of frequent worldwide power outages. And let's not forget about the weather. With a larger surface area, the Earth's climate would be more extreme. The poles would be colder, the equator hotter, and the storms, well, stormier. So, what have we learned from this hypothetical journey? A larger Earth would bring about heavier gravity, potentially larger land animals due to a denser atmosphere, a stronger magnetic field offering better protection against solar radiation, but also more intense geomagnetic storms and extreme weather conditions. It's intriguing to imagine how life would adapt and evolve under these conditions. But for now, we reside on our perfectly sized Earth, a place that, for all its faults and challenges, is uniquely suited to support the diverse life that calls it home. So while it's fun to speculate about life on a larger Earth, perhaps it's also a reminder to appreciate the planet we've got. Imagine waking up one morning and seeing nothing but darkness. No sunrise, no daylight. What if the sun suddenly disappeared? It's a chilling thought, isn't it? The sun, our closest star, is so much more than just a source of light. It's the linchpin of life as we know it, a cosmic powerhouse that does more than just brighten our days. Let's dive in. The sun provides us with warmth, a critical element for life on Earth. It's like the world's thermostat, maintaining the delicate balance that allows life to thrive. Without the sun's heat, our planet would quickly become a frozen wasteland, devoid of the conditions necessary for life. But the sun's influence transcends temperature. It's also the engine that drives our weather. Solar heat warms the atmosphere, oceans and land, creating wind, powering ocean currents and fueling the water cycle. Without the sun, there would be no rain, no snow, no storms. Our world would be a static, silent sphere, but that's not all. The sun also plays a crucial role in sustaining life on Earth. It fuels photosynthesis, the process by which plants convert sunlight into the energy they need to grow. This process produces oxygen, a gas vital for most forms of life, including us, humans. And it doesn't end there. The sun's gravitational pull keeps our planet in a stable orbit. Without it, Earth would be set adrift in the vastness of space, a rogue planet without a star to call home. Now, let's talk about the sun's life cycle. Like all stars, the sun was born, it lives, and it will eventually die. But don't panic just yet. Scientists estimate the sun is middle-aged in star years and has about 5 billion years left. The possibility of its disappearance, while theoretically possible, is not something we need to worry about in our lifetime. The sun's disappearance isn't just about darkness, it's an event that would transform life as we know it. So next time you enjoy a sunny day, take a moment to appreciate our amazing sun, the true star of our solar system. The moment the sun vanishes, we wouldn't know for about 8 minutes and 20 seconds. An odd fact, isn't it? Let's unpack this. The sun is about 93 million miles away from us. Light travels at a mind-boggling speed, around 186,000 miles per second to be precise. So, the sunlight we're basking in at any moment actually left the sun's surface about 8 minutes and 20 seconds ago. So, if the sun were to suddenly cease to exist, we'd be blissfully unaware of this cosmic catastrophe for just over 8 minutes. It's a bit like living in the past, in a sense. But once those 8 minutes are up, the real fallout begins. First, the world would plunge into darkness. The sun, our primary source of light, is gone. No more daylight, just an eternal night. This isn't your ordinary power outage. Streetlights won't save us this time. We're talking about a darkness so complete it's hard for us to truly comprehend. Next, we'd feel the loss of the sun's gravitational pull. The Earth, along with the other planets in our solar system, are kept in their respective orbits by the sun's gravity. Without it, the Earth would no longer be tethered to its path. We'd start drifting off into space, embarking on a lonely and aimless journey through the cosmos. And let's not forget the immediate drop in temperature. The sun is our primary source of heat. Without it, temperatures would plummet. The world would quickly start to freeze over, beginning with the surface, and eventually extending deep into the Earth's crust. The immediate aftermath is swift and disorienting, but the long-term effects are even more catastrophic. As we move forward, we'll delve into what happens next, the long-term consequences of a sunless universe. But for now, let's take a moment to appreciate the sun, the star at the center of our lives and our world. As the warmth fades and temperatures plummet, the Earth becomes a frozen wasteland. In this sunless reality, our planet experiences a global cooling of epic proportions. As sunlight no longer reaches us, we see the average temperature of the Earth's surface plunge swiftly. Within a week, the average global surface temperature would fall below freezing. After a year, it would plummet to -100 degrees Fahrenheit. But the cold is just one facet of this chilling scenario. Photosynthesis, the life-sustaining process by which plants convert sunlight into energy, would cease. Without the sun's energy, plants would be unable to produce oxygen, a vital gas that we humans and countless other species need to survive. Not only would our planet's oxygen supply be in jeopardy, but our food chains would also collapse. The extinction of plants would lead to the demise of herbivores, followed by the predators that feed on them. In essence, the sun's disappearance would be a death sentence for most life forms on Earth. But what about us, the supposedly intelligent and adaptable humans? Could we defy the odds and find a way to survive in this sunless world? Our best bet would be to go underground. Deep within the Earth, conditions are more stable and temperatures don't fluctuate as drastically as they do on the surface. We could create subterranean habitats, insulated from the icy world above. To power our new underground homes, we could harness geothermal energy, which is heat derived from the Earth's core. This energy source is not reliant on the sun and would provide us with the necessary warmth and power. However, even with our technological prowess, life would be incredibly challenging. The lack of sunlight would affect our mental health, and food would be scarce. We would have to grow crops using artificial light and cultivate mushrooms which don't require sunlight. Without the sun, Earth transforms into a dark, icy, and inhospitable world. But despite the grim outlook, the human spirit, coupled with our ingenuity, may just give us a fighting chance. The sun's disappearance doesn't just affect Earth, it alters the entire solar system. The sun, our glowing life-giving beacon, plays a far more significant role than merely lighting up our blue skies and warming our days. It's the gravitational anchor that keeps our solar system together. Imagine the sun as the center of a cosmic whirligig, with planets, asteroids, and comets all dancing around it, held in place by its immense gravitational pull. Now picture this. The sun suddenly vanishes. With the gravitational tether gone, the planets would no longer have a central point to orbit. Instead, they would continue moving in a straight line along their current paths at the same speed they were traveling when the sun disappeared. This phenomenon, known as Newton's first law of motion, describes an object in motion staying in motion unless acted upon by an external force. Our Earth, along with the other planets, would become rogue planets wandering the cosmic void. But what about the smaller bodies in our solar system like asteroids and comets? They too would be set adrift, becoming interstellar nomads. The asteroid belt, a region of space between Mars and Jupiter teeming with rocky bodies, would disperse. The same goes for the Kuiper belt, a distant ring of icy objects beyond Neptune's orbit, including Pluto. And the Oort cloud, a theorized sphere of icy bodies at the very edge of our solar system. It would lose its gravitational shepherd, sending comets spiraling into the depths of space. In essence, our solar system as we know it would cease to exist. The planets we've come to know and study, the asteroid and Kuiper belts, the Oort cloud, all these familiar features would be scattered across the cosmos, leaving behind a vast empty space where the sun once reigned. Without the sun, our solar system would be unrecognizable. The scenario of the sun vanishing may sound like science fiction, but it's a reminder of our dependency on this star. Indeed, the sun isn't just a glowing ball in the sky that provides us with daylight. It's the cornerstone of our existence, the engine of life on Earth, and the anchor of our solar system. We've explored this in depth throughout our journey, from the chilling immediate aftermath of the sun's disappearance to the long-term consequences and the unimaginable reality of a universe without the sun. The sun's ceaseless nuclear fusion process sustains life on our planet. It's the sun's energy that powers photosynthesis, the process that fuels the growth of plants, our primary food source, and the producers of the oxygen we breathe. Without the sun, this cycle of life would come to a standstill. But it's not just about us. The sun's gravitational pull keeps our planet and its fellow celestial bodies in their respective orbits. Without this gravitational anchor, the planets would drift off into space, resulting in a destabilized solar system. And yet, this catastrophic scenario isn't just the stuff of nightmares or blockbuster movies. It's a stark reminder of our place in the universe and our profound reliance on the sun. It underscores the need for us to respect and protect the limited resources we have on Earth, as we have no other place to go should the sun's light ever go out. Understanding these catastrophic scenarios and the sun's pivotal role in our existence can help us appreciate it more. It's easy to take the sun for granted given its constant presence. But as we've seen, its absence would bring about cataclysmic changes that we wouldn't be able to survive. So the next time you bask in the sun's warmth, remember, it's more than just light and heat, it's the life force of our— Have you ever wondered what life would be like on Saturn? A tantalizing proposition, isn't it? A life not bound by the familiar confines of our blue planet, but instead, amidst the gaseous swirls and icy rings of Saturn. This isn't just fanciful thinking, it's an exploration into the realm of possibility. Today, we're embarking on a journey to the sixth planet from the sun, a place where day and night take on whole new meanings. Imagine a life, not on Earth, but on the sixth planet from the sun. Saturn, a gas giant, poses a unique set of challenges for life as we know it. The planet is a truly fascinating celestial body, and it's quite different from our home planet in many ways. Let's start with its atmosphere. Saturn's atmosphere is primarily composed of hydrogen and helium, much like the sun. There's also a touch of methane, ammonia, and water vapor, but oxygen, the gas we humans need to breathe, is conspicuously absent. So unless we develop a way to breathe hydrogen or helium, we're going to need to bring our own air supply. Now let's talk about the temperature. Saturn is a chilly place even compared to the coldest places on Earth. The average temperature on Saturn is about -285 degrees Fahrenheit. That's colder than any temperature ever recorded on Earth. To put it in perspective, that's so cold that most gases we're familiar with would freeze solid. Next up is gravity. Saturn's gravity is only about 92% of Earth's. That might not sound like a big difference, but it could have significant effects on the human body over time. For example, our muscles and bones could weaken from lack of use. And then there's the weather. Saturn is known for its intense and long-lasting storms. The most famous of these is the Great White Spot, a storm system that can be seen from Earth and lasts for months. The winds in these storms can reach speeds of up to 1,000 miles per hour, much faster than any hurricane on Earth. Finally, it's worth mentioning that Saturn doesn't have a solid surface. The planet is mostly made up of swirling gases and liquids. So even if we could withstand the harsh atmosphere, extreme cold, and intense storms, we'd still have nowhere to stand. The inhospitable environment of Saturn makes it a challenging yet intriguing prospect for human habitation. Let's delve into what a typical day might look like on Saturn. The day begins, but not as we know it. You see, on Saturn, a single day lasts just over 10.5 hours. That's right, your entire day from sunrise to sunset happens in less time than most of us spend at work on Earth. So, if you're a fan of those long, lazy summer days, Saturn might not be the place for you. Sleep cycles would have to adapt to this rapid rhythm. You might find yourself catching quick power naps throughout the Saturnian day, rather than one long sleep. Imagine, if you will, a series of short dreams, each one a brief escape from the alien world outside. Food consumption would also be a unique affair. With the lack of arable land, traditional farming as we know it would be out of the question. Instead, we might see the rise of lab-grown food, nourishing our bodies with scientifically optimized meals. Perhaps we'd even take a leaf out of the astronaut's book, with vacuum-packed meals becoming the norm. Now, communication on Saturn would be a challenge, to say the least. With the average distance to Earth being over 800 million miles, sending a simple hello back home would take over an hour. That's a long wait for a reply to your text messages. And let's not forget the weather. You thought Earth's weather was unpredictable? Saturn's storms are on a whole other level. With winds reaching over 1,000 miles per hour, stepping outside for a breath of fresh air might not be the wisest idea. Life on Saturn would be a dance with the extreme. Every aspect of daily life, from the rhythm of sleep to the way we eat and communicate, would need to adapt to the harsh realities of this gas giant. Life on Saturn would indeed be a radical departure from our earthly routines. Surviving on Saturn would be no small feat. The challenges are many, and they are formidable. First and foremost, there's the issue of breathable air, or rather the lack thereof. Saturn's atmosphere is primarily composed of hydrogen and helium, with traces of methane and ammonia. Not exactly a breath of fresh air, is it? For humans to breathe, we'd need a continuous supply of oxygen, something that is conspicuously absent on Saturn. Then we have the issue of Saturn's extreme temperatures. Even the warmest day on Saturn is cold enough to freeze you solid. The average temperature on this giant gas planet is a bone-chilling minus 285 degrees Fahrenheit. And if you thought that was cold, the temperature drops even further the deeper you go into the planet. Another significant challenge is the high radiation levels. Saturn's magnetic field traps high-energy particles from the sun, creating radiation belts that would be harmful to humans and technology alike. To live on Saturn, we'd need advanced shielding to protect us from this harmful radiation. But let's not forget about gravity. Saturn's gravity is slightly less than ours on Earth, but it's enough to cause significant health problems over time. We're talking muscle and bone loss, and that's just the tip of the iceberg. So, how do we overcome these challenges? It would require technological advancements far beyond what we currently possess. We'd need to develop new materials and technologies capable of withstanding Saturn's extreme conditions. We'd need to create self-sustaining habitats with their own sources of oxygen and food. And we'd need advanced radiation shielding and gravity simulators to protect us from the harsh realities of life on Saturn. These challenges are daunting, no doubt, but they also represent an opportunity, a chance to push the boundaries of what's possible. They force us to innovate, to adapt, to evolve, and in doing so, they remind us of the very essence of what it means to be human. Facing these obstacles, survival on Saturn becomes a test of human ingenuity and resilience. Despite the challenges, life on Saturn could offer unprecedented opportunities. Imagine the frontier of scientific exploration that Saturn could provide. This gas giant holds mysteries that could keep scientists busy for centuries. Saturn's complex and dynamic atmosphere, its iconic rings and its multitude of moons, could provide new insights into the formation of our solar system and the nature of the universe itself. Each discovery would be a leap forward in our understanding, a new piece in the vast cosmic puzzle. Just as the gold rush drove westward expansion in the 19th century, Saturn could be the site of a resource rush in the 21st century. Beneath its swirling clouds, Saturn is believed to hold vast reserves of helium-3, a rare isotope on Earth that could be a game-changer in the field of nuclear fusion. If we could harness this potential energy source, we might solve our planet's energy problems and open up a new era of clean, virtually limitless power. Living on Saturn would also inevitably lead to the development of new technologies. The harsh conditions would demand solutions we can't yet imagine. We'd need to develop advanced materials to withstand the intense pressure and cold, new methods of transportation to navigate the planet's massive size and gravitational pull, and innovative means of communication to stay connected with each other and with Earth. Each of these advancements would not only help us survive on Saturn, but could also be used to improve life back on our home planet. And let's not forget the potential for personal growth. The pioneers who choose to live on Saturn will become a new breed of humans, resourceful, resilient, and adaptable. They'll learn to work together in ways we can only dream of, building a society that's truly out of this world. The harsh environment of Saturn could paradoxically be a cradle for human innovation and progress. Living on Saturn remains a fascinating yet daunting prospect. As we've journeyed through this exploration, we've uncovered the many layers of this complex proposition. Imagine waking up to a sky filled with rings of ice and rock, a sight that would never cease to amaze, yet the reality of such a life isn't as idyllic as the view. The hostile environment of Saturn, with its extreme temperatures, violent storms, and lack of solid ground, poses significant challenges. Everyday activities we take for granted on Earth, from a simple walk to breathing fresh air, would become insurmountable tasks. Yet, within these challenges, lie opportunities. The presence of water ice in the rings and the potential for hydrocarbons in the atmosphere open up possibilities for resource extraction and energy production. Not to mention, the gravity on Saturn is less than on Earth, which could lead to interesting adaptations in our physiology and technology. However, it's essential to remember that these are mere speculations, fascinating conjectures born out of our innate curiosity and thirst for knowledge. The reality of living on Saturn, as it stands today, is beyond our current technological and biological capabilities. So, the next time you gaze upon the night sky and spot Saturn, ponder on this. What if we lived on Saturn? Have you ever wondered if we could live on Pluto? The idea might sound like a plot from a futuristic sci-fi novel, but it's a question that tickles the curiosity of many. Pluto, a dwarf planet situated in the cold, far-flung reaches of our solar system, has always been a subject of fascination. Discovered in the early 20th century, this celestial body was once considered the 9th planet from the Sun. However, its status was later demoted to that of a dwarf planet. a decision that sparked a heated debate among the scientific community and beyond. Despite its icy demeanor, Pluto holds a certain charm that draws us towards the intriguing possibility of life beyond our blue planet. Could we, as humans, ever call this distant icy world home, or is it just a fantasy confined to the realms of science fiction? Now, we dive into the realm of science and imagination, exploring the possibility of life on Pluto. First off, we need to understand Pluto's environment. Pluto, the dwarf planet at the edge of our solar system, has an environment that is as unique as it is harsh. The first thing that strikes you about Pluto's environment is the cold. It's not just chilly or frosty, it's bone-chillingly, mind-numbingly cold. Temperatures here can drop to more than 400 degrees below zero Fahrenheit, which is colder than anything we experience on Earth. This extreme cold would instantly freeze any exposed human tissue, turning it as hard as rock. Not only that, but Pluto also has a very thin atmosphere. It's so thin that it's about 100,000 times less dense than Earth's atmosphere. That's so thin that if you were to try and take a breath, you'd be gasping for air. This lack of atmosphere also means there's no protective layer to shield the surface from cosmic radiation. This constant bombardment of cosmic rays would be lethal to humans without proper protection. Then there's the issue of sunlight, or rather the lack of it. Pluto is about 3 billion miles away from the sun. That's about 40 times further than Earth. This means that the sunlight that does reach Pluto is so dim that it would look like twilight on Earth, even at high noon. This lack of sunlight would make it extremely difficult for humans to see, and it could also have serious effects on our mental health. And let's not forget about the terrain. Pluto's surface is covered with mountains of ice that are as tall as the Rockies, and vast plains of frozen nitrogen. This harsh terrain would make any movement difficult and dangerous. So, to sum it up, the environment on Pluto is incredibly harsh. It's freezing cold, there's barely any atmosphere, sunlight is scarce, and the terrain is treacherous. Simply put, Pluto's environment is brutal and unforgiving. So, what would be the challenges of living on Pluto? Right off the bat, the lack of breathable air presents a significant hurdle. Unlike the oxygen-rich atmosphere we enjoy here on Earth, Pluto's air primarily consists of nitrogen with minor traces of methane and carbon monoxide. Let's just say that without a supply of oxygen, we'd have to rely heavily on advanced life support systems to stay alive. Next, we'd have to contend with the extreme cold. It's not just chilly on Pluto, it's downright frigid. Temperatures can plummet to a bone-chilling minus 375 degrees Fahrenheit. To put this into perspective, even the coldest temperature ever recorded on Earth is balmy compared to a warm day on Pluto. Survival would demand the most advanced insulation and heating technologies we have at our disposal. Then there's the matter of gravity, or rather the lack of it. Pluto's gravity is only about 6% as strong as Earth's. This means our bones and muscles would weaken over time, posing a serious health risk. We'd need to develop rigorous exercise routines and possibly even new medical treatments to combat these effects. Don't forget about isolation. Pluto is, on average, over 3 billion miles away from Earth. That's not exactly a quick trip. The isolation would be extreme, and communication with Earth would be delayed by several hours. Psychological resilience would be just as important as physical strength. Finally, there's the journey itself. Even at the speed of our fastest spacecraft, it would take us about 9.5 years to get to Pluto. That's a long time to be cooped up in a spaceship, and it doesn't even include the time it would take to establish a viable living environment once we arrive. Indeed, living on Pluto would be a monumental challenge. But as we've seen throughout history, human ingenuity often rises to meet the most daunting of challenges. Will we one day call Pluto home? Only time will tell. Could humans adapt to these harsh conditions? That's the billion-dollar question. The human body is a marvel of adaptability. But let's consider the monstrous circumstances we'd be up against on Pluto. Firstly, there's the physical aspect. The human body is optimized for conditions on Earth, where gravity, temperature, and radiation levels are just right. But on Pluto, we'd be grappling with an environment that's over 300 degrees below freezing, bathed in cosmic radiation, and where gravity is only 1/6 of what we're used to. Our bodies would need to cope with these drastic changes. For instance, less gravity would weaken our muscles and bones over time. The extreme cold would require us to conserve as much heat as possible, and the radiation would pose a constant health risk. Then there's the psychological aspect. The isolation, the darkness, and the sheer alienness of Pluto could take a toll on our mental health. Humans are social creatures, and living in such an inhospitable environment, far from the warmth and familiarity of Earth, could lead to stress, anxiety, and a host of other psychological issues. But fear not, for technology might be our savior. Advanced spacesuits could protect us from the cold and radiation, and artificial gravity could help maintain our physical health. Habitats could be designed to mimic Earth's conditions, with indoor parks and virtual reality simulations to help us feel less isolated. We could even use telecommunication technology to stay connected with our loved ones back home. Of course, these are just potential solutions. We're still a long way from making them a reality. But as we've seen throughout history, humans have an uncanny ability to adapt and innovate in the face of adversity. We've evolved from cave dwellers to astronauts, from horse riders to jet pilots. The human species is adaptable, but living on Pluto would test our limits. Despite the challenges, could we ever live on Pluto? This question might seem a bit far-fetched now, but let's take a look at the possibilities that the future might hold. Advancements in technology are rapidly transforming our world and expanding our horizons. As we delve deeper into the realm of space exploration, the potential for future technology to make life on Pluto a reality cannot be entirely dismissed. We're talking about cutting-edge developments in terraforming, artificial habitats, and space travel that could potentially make the inhospitable conditions of Pluto livable for humans. There's a tremendous scientific interest in Pluto. This distant, icy dwarf planet holds many secrets that could provide us with valuable insights into the origins of our solar system and the universe. By establishing a base on Pluto, we could expand our understanding of these mysteries, pushing the boundaries of our knowledge and capabilities. Imagine a base on Pluto serving as a stepping stone for further exploration into the Kuiper Belt and beyond. Such a base could also act as a research station, allowing scientists to study Pluto's unique environment up close and personal. The potential benefits are immense, from unlocking the secrets of cosmic evolution to perhaps even discovering new resources or forms of life. Moreover, living on Pluto could redefine our perspective of survival and adaptability. It could teach us to thrive in extreme environments, a vital skill that might be required as we venture further into the cosmos. But let's not get carried away. The path to life on Pluto is fraught with colossal challenges. We would need to overcome extreme temperatures, lack of atmosphere, and the vast distance from Earth, to name just a few. Yet, it's important to remember that every great journey begins with a single step. And who knows, perhaps one day the footprints of that step will be etched into the icy surface of Pluto. While the challenges are enormous, the future may hold the possibility of life on Pluto. To sum up, is Pluto our next home? Well, we've journeyed through the intriguing idea, dived deep into the brutal environment, and grappled with the enormous challenges of making such an extreme place our home. We've even examined the potential for human adaptation, the incredible ways we might evolve to survive in such a harsh landscape. From the extreme cold, to the thin atmosphere, to the long, dark winters, Pluto is not for the faint of heart. Yet, we've also explored the incredible potential for future advancements, the ways technology might make living on this distant dwarf planet a reality. We've seen that, while fraught with difficulties, there's also a hint of possibility. The future, after all, is a place of endless potential, filled with the unknown and the yet to be discovered. And so we end with the question we began with, but perhaps with a deeper understanding. For now, living on Pluto remains a fascinating but distant possibility, yet who knows what the future holds? Have you ever wondered about the mysteries that our universe holds? What if one of those mysteries was right in front of you? Our universe, a vast expanse of time and space, is brimming with enigmas that boggle the mind. From the smallest subatomic particles to the largest galaxies, every corner of the cosmos is teeming with intrigue and wonder. It's a labyrinth of celestial bodies and phenomena, each more perplexing than the last. The stars that twinkle in the night sky, the planets that orbit them, the black holes that swallow everything, and the galaxies that house them all. Each element of our universe is a riddle waiting to be solved. And yet, amid this cosmic jigsaw, there are mysteries that remain largely untouched, their secrets veiled by the sheer complexity of their nature. One such mystery that has fascinated scientists and astronomers alike is the concept of white holes. Before diving into the concept of white holes, imagine a black hole, a region in space where gravity is so strong that nothing can escape, not even light. Now hold that image in your mind as we flip the script. Welcome to the fascinating world of white holes. Theoretical entities that are, in essence, the mirror image of black holes. If black holes are the ultimate cosmic vacuum cleaners, white holes are the ultimate cosmic sprinklers. Black holes are regions of space-time with gravitational forces so intense that nothing, not even particles or electromagnetic radiation like light, can escape from inside them. They're like cosmic roach motels. Everything checks in, but nothing checks out. Now imagine a cosmic object that's the exact opposite. Instead of an insatiable gravitational pull that sucks everything in, it possesses an incredible force that repels everything. This is the concept of a white hole. While black holes are constantly gobbling up matter and energy, white holes could theoretically be continually belching them out. Picture a cosmic geyser, continually erupting with matter and energy. However, it's crucial to note that while we have solid evidence for the existence of black holes, white holes remain purely in the realm of theoretical physics. They're solutions to Einstein's equations of general relativity that exhibit this repelling behavior, yet we've never observed one. The idea is that a black hole distorts space and time so much that maybe, just maybe, it could puncture a hole through the fabric of reality itself, creating a gateway or a wormhole to another universe or another time. And on the other end of this theoretical wormhole, a white hole, spewing out everything that the black hole sucked in. To put it all together, if a black hole is a cosmic trapdoor from which nothing can escape, a white hole is like a cosmic fountain, continuously spewing out matter and energy. In simple terms, while a black hole sucks in all matter, a white hole is said to spit it out. But the question remains, if black holes exist, do white holes exist too? To dive into this mystery, we must first understand that our knowledge of the cosmos is largely based on theories and hypotheses, conjectures built on layers of scientific analysis and mathematical calculations. White holes in this context are a fascinating conjecture, a theoretical possibility that emerges from the equations of general relativity, the very same equations that predicted the existence of black holes, which have since been observed and studied. Here's the interesting bit. Black holes, as we know, are regions of space-time exhibiting such strong gravitational effects that nothing, not even particles or electromagnetic radiation such as light, can escape from inside them. White holes, on the other hand, are the theoretical opposites. They are regions of space-time which cannot be entered from the outside, but from which matter and light could escape. In simple terms, if a black hole is an entrance, a white hole could be an exit. But, if black holes are voracious consumers, swallowing everything that comes too close, and white holes are the ultimate cosmic spitballs, why haven't we observed any white holes? Well, that's where the mystery deepens. Some cosmologists suggest that white holes could be incredibly unstable, collapsing upon themselves before they could be observed. Others propose that white holes might exist in other universes as part of the multiverse theory. It's also important to note that while black holes have been observed and their existence is well accepted, the existence of white holes remains purely theoretical. We don't have any direct observational evidence for white holes as we do for black holes. Despite the lack of empirical proof, the theoretical possibility of white holes continues to stimulate scientific discussion and inspire flights of imagination. The existence of white holes, though not yet proven, remains a tantalizing possibility. The cosmos, as always, keeps us guessing, and every answer we find seems to bring with it a host of new questions. As we delve deeper into the mysteries of the universe, who knows what we might discover next? Now, let's imagine for a moment, what would happen if you entered a white hole? This is a question that has puzzled scientists for decades. The truth is, we don't know for sure, but let's dive into the realm of the theoretical and explore some possibilities. Firstly, one must understand that white holes, like their counterparts, black holes, possess extreme gravitational forces. These forces are so strong that they warp the fabric of space-time itself, creating a vortex of sorts, a tunnel through the cosmos. Now, if you were to approach a white hole, these powerful gravitational forces would begin to affect you. The closer you get, the stronger these forces become. And these forces are not uniform. They are much stronger at your feet than at your head, assuming you're approaching feet first. This differential in force would stretch you out, much like a piece of spaghetti. This phenomenon, aptly named spaghettification, would be your likely fate if you were to journey too close to a white hole. But let's take a step back. What if you could somehow survive this extreme stretching? What then? Well, you'd find yourself in a strange and alien environment. The laws of physics as we know them would be distorted, contorted by the immense gravitational pull of the white hole. Time and space would seem to bend and twist around you, creating a surreal and otherworldly experience. And what if you made it all the way through? Would you emerge on the other side in some distant part of the universe, or perhaps even another universe altogether? Again, we simply don't know. The math suggests it's possible, but until we can test these theories, they remain just that, theories. What we do know is that, much like their black hole counterparts, white holes do not seem to offer a return journey. Once you've crossed the event horizon, there's no turning back. A journey into a white hole, much like a black hole, would be a one-way trip. Why does the concept of white holes matter? Well, the significance of white holes is incredibly profound. They are a cornerstone in the field of astrophysics, offering a unique perspective that challenges what we know, or think we know, about the universe. As we delve deeper into the mysteries of the cosmos, white holes could potentially shed light on some of the most elusive phenomena that baffle scientists today. In the grand cosmic ballet, black holes are known for their voracious appetites, gobbling up anything that ventures too close. But if white holes do exist, they could be the cosmic spewing counterpoints to black holes, a fascinating possibility that could redefine our understanding of matter and energy flow in the universe. The idea that matter and energy could emerge from these celestial entities, rather than being swallowed up, is a radical departure from traditional astrophysical norms. Moreover, white holes could offer insights into the enigma of dark energy and dark matter. These are two of the biggest mysteries in astrophysics today, making up a whopping 95% of the universe. Yet, despite their prevalence, we know very little about them. If white holes are real, they could be the missing piece of the puzzle, helping us unravel these cosmic conundrums. White holes could also potentially play a role in the study of quantum gravity, a field that attempts to reconcile quantum mechanics with general relativity. This would be a game-changer, helping us to address some of the most fundamental questions about the nature of space and time. Finally, the concept of white holes stirs the pot of scientific and philosophical debate. It challenges us to think outside the box, to question our assumptions, and to always keep exploring. After all, the universe is a vast, ever-changing tapestry of mysteries waiting to be unraveled. The mysteries of white holes continue to captivate us, fueling our curiosity and our drive to understand the universe. The universe is full of mysteries, and white holes are just one of them. This cosmic conundrum, the theoretical counterpart to a black hole, has been a topic of fascination and debate amongst scientists and astrophysicists worldwide. We've delved into the concept of white holes, exploring their theoretical existence based on the principles of quantum mechanics and general relativity. We've journeyed into the heart of a white hole, a journey of pure speculation and imagination, given their elusive nature. We've also examined the significance of white holes, their potential role in the creation of new universes, and their implications for our understanding of space-time. These celestial enigmas challenge our perception of the cosmos and push the boundaries of our scientific understanding. As we continue to explore the cosmos, who knows what other mysteries we might unravel. Imagine on a regular day an asteroid, a cosmic stone hurtling through space, picks Antarctica as its target. Picture a behemoth from the cosmos with tremendous speed, zeroing in on our icy continent. Just think about the sheer vastness of these celestial nomads, some even larger than a small city, moving at unimaginable speeds. This is no science fiction, it's a potential reality. A reality where the frosty tranquility of Antarctica is shattered by an extraterrestrial trespasser. A chilling possibility, isn't it? But what happens next? The moment the asteroid touches the icy continent, a chain of cataclysmic events is set into motion. Picture this. A cosmic behemoth, born in the depths of space, descends upon Earth with a terrifying speed. It strikes Antarctica, the icy, desolate expanse at the bottom of our world. Upon impact, the asteroid creates an incredible crater, a gaping wound in the Earth's crust. This crater, kilometers wide and deep, is the first visible sign of the asteroid's devastating arrival. But the physical damage is just the beginning. The asteroid's impact releases an unfathomable amount of energy. Imagine the most powerful nuclear bomb ever detonated. Now multiply that by 100, 1,000, or even more. That's the kind of energy we're talking about. The heat generated by the impact is so intense that it vaporizes the ice and rock within the immediate vicinity, transforming them into a fiery, high-speed ejecta. This energy doesn't just vanish, it's transferred into the ground, into the air, into the ice. It's like dropping a massive stone into a still pond. The shock wave from the impact radiates outwards, ripping through the Antarctic ice like a hot knife through butter. The shock wave doesn't stop there. It travels at supersonic speeds, causing destruction far beyond the initial impact site. The shock wave, combined with the intense heat, triggers massive ice melts. Gigantic chunks of ice break off and tumble into the ocean, causing sea levels to rise. The immediate vicinity of the impact site is transformed into a hellish landscape, a stark contrast to the frozen wilderness it once was. And here's where it gets really scary. The dust and debris thrown up by the impact don't just fall back down, they get swept up into the atmosphere, blocking out the sun and plunging the world into darkness. This is known as an impact winter, and it can last for months, even years. The immediate aftermath is catastrophic, but the ripple effects are even more concerning. The shockwave from the impact and the subsequent effects would be felt worldwide. It wouldn't just be a localized event, confined to the icy plains of Antarctica. No, this would be a global catastrophe, and the ripples of its disaster would touch every corner of our planet. First off, let's consider the tsunamis. Now, these aren't your everyday run-of-the-mill waves. When an asteroid, especially one of significant size, smashes into the Earth, it displaces an enormous amount of water. This displacement triggers tsunamis, colossal waves that would race across the world's oceans at jet speeds. Coastal cities, islands, and communities would be at the mercy of these gargantuan waves, leading to unimaginable devastation. But the horror doesn't stop there. As the asteroid crashes into Antarctica, it would hurl vast amounts of dust and debris into the atmosphere. This could potentially block out sunlight, plunging the Earth into what's known as a nuclear winter. Now, contrary to its name, a nuclear winter doesn't mean radioactive snowflakes. It's actually a significant drop in temperature caused by the sun's rays being blocked. This would disrupt the Earth's climate, leading to widespread crop failures and famine. Changes in weather patterns would be another consequence of this cataclysmic event. The dust and debris in the atmosphere would not only block out the sun, but also affect the planet's weather systems. This could lead to unpredictable and severe weather conditions all over the globe. Droughts, floods, extreme cold, or heat waves could become the new norm. And while all this is happening, the world would be grappling with the loss of Antarctica's unique ecosystem and the potential release of ancient viruses and bacteria locked away in the ice for millennia. It's a grim picture, isn't it? But what about the icy continent itself? What happens to all that ice? Antarctica, home to about 70% of the planet's fresh water frozen in ice, would face a catastrophic meltdown. This icy continent, with its vast, untouched wilderness, is nothing short of a ticking time bomb if an asteroid were to strike. Imagine, if you will, the colossal force of an asteroid impact, resulting in a significant portion of this frozen reservoir thawing instantaneously. The heat generated by the impact would be so intense that it would cause a drastic melting of Antarctic ice. This sudden influx of melted ice would cause sea levels around the world to rise rapidly. We're not talking about a small increase here. We're looking at a global-scale event that could raise sea levels by several meters. Coastal cities, many of which are barely above sea level as it is, would face unprecedented flooding. Places like New York, London, and Shanghai could find themselves partially submerged. But the effects wouldn't stop at the water's edge. The sudden rise in sea levels would also dramatically alter ocean currents. These currents, driven by temperature and salinity differences, play a crucial role in regulating our planet's climate. A disruption to this system could lead to drastic changes in weather patterns, potentially triggering a new ice age or intensifying global warming. The influx of fresh water into the oceans could also have catastrophic effects on marine life. The delicate balance of salt and fresh water is vital for the survival of many marine species. An asteroid impact could upset this balance, leading to massive die-offs and possibly even the extinction of certain species. The meltdown paints a grim picture, but the story doesn't end there. This scenario paints a clear picture of the potential disaster that an asteroid strike in Antarctica could unleash. But as we'll see in the next scene, the long-term impacts could be even more devastating. The long-term consequences of such an event would alter life on Earth as we know it. The colossal energy released on impact would not only result in immediate devastation, but also set in motion a series of events that could change the course of life on our planet. Let's first consider mass extinctions. The asteroid's impact could potentially wipe out numerous species unable to adapt to the sudden shift in their environment. This isn't a far-fetched theory. About 65 million years ago, a massive asteroid strike is believed to have led to the extinction of the dinosaurs. In our case, the impact's aftermath, combined with the drastic climate change, could prove too much for many species. Speaking of climate change, the long-term impact on Earth's climate could be cataclysmic. The initial heat pulse would cause a significant portion of Antarctica's ice to vaporize instantly, leading to a sudden increase in sea levels worldwide. This, coupled with the enormous amount of dust and soot projected into the atmosphere, could result in what scientists refer to as an impact winter. This is a period of prolonged cold weather due to a reduction in the sunlight reaching Earth's surface, causing a drop in global temperatures. The resulting cooler climate could last for several years, severely disrupting ecosystems and agriculture. As for the impact on human civilization, it would be profound. Cities near the coasts could be submerged due to rising sea levels. The drastic climate change could lead to a global food crisis, as agriculture struggles to adapt to the new conditions. The world as we know it would change dramatically, and survival would become our primary concern. The long-term effects of an asteroid hitting Antarctica are indeed grim and far-reaching. We would witness a shift in the dynamics of life on Earth, with survival becoming a daily struggle for many species, including our own. An asteroid hitting Antarctica would have far-reaching and long-lasting effects. So, an asteroid hitting Antarctica? It's a cataclysmic event with global consequences. Imagine a cosmic projectile hurtling through space, destined for a collision course with Earth. The impact, as we've discussed, would be immediate and devastating. The shockwaves from the collision would ripple across the Earth, causing seismic disturbances and triggering tsunamis. But it doesn't end there. The global consequences would be far-reaching. Dust and debris thrown high into the atmosphere would block out sunlight, leading to a dramatic drop in temperatures, a nuclear winter, if you will. This fallout would disrupt ecosystems worldwide, leading to mass extinctions and threatening our very existence. The meltdown of Antarctica's ice is another grim scenario. The heat from the impact would instantly vaporize massive amounts of ice, causing a rapid rise in sea levels. Cities across the globe would be submerged, displacing millions. The long-term effects? Well, they're not pretty. The Earth's climate would be altered for thousands of years. Life as we know it would change in ways we can hardly comprehend. Yet, despite the grim picture we've painted, it's important to remember that such an event is highly unlikely. But it's not impossible. Though the chances are slim, it's a sobering reminder of the power of the cosmos and our place in it. The universe is vast, and we're just a tiny part of it, dancing to its whims. It's a humbling thought, isn't it? Have you ever pondered about the existence of alien life? Could we possibly be alone in this vast universe? It's a question that has sparked the curiosity of mankind for centuries. As we gaze up at the twinkling stars, we can't help but wonder if somewhere out there, in the inky blackness of space, there could be other beings, perhaps gazing back at us. The universe is a vast, almost incomprehensible expanse. It's home to an estimated 2 trillion galaxies, each containing billions, even trillions of stars. Around these stars orbit countless planets, many of which could potentially harbor life. The numbers alone seem to suggest that we can't be alone. Yet, despite our best efforts and technological advancements, we have so far found no concrete evidence of extraterrestrial life. This is where the James Webb Telescope comes into play. As the successor to the Hubble Space Telescope, the James Webb is equipped with a suite of state-of-the-art instruments designed to peer deeper into space than ever before. Its mission? To answer some of the biggest questions in astronomy, including the age-old question of whether we are alone in the universe. The James Webb is poised to study the atmospheres of distant exoplanets, looking for telltale signs of life such as water vapor, methane, and oxygen. These so-called biosignatures could potentially indicate the presence of alien life. Of course, the discovery of alien life would not necessarily mean little green men or advanced civilizations. Life, as we understand it, begins with simple, single-celled organisms. Detecting such life forms on distant planets would be a monumental achievement, fundamentally changing our understanding of our place in the universe. In the end, the question of alien life is not just about whether we are alone, it's about our place in the universe, about understanding the origins and the diversity of life. It's a question that transcends science, touching on philosophy, religion, and the very core of human curiosity. The James Webb Telescope might be the key to unlocking these cosmic mysteries. The James Webb Telescope wasn't born overnight. It's a product of years of scientific innovation and commitment, a testament to the relentless human spirit that dares to dream bigger and reach further. This magnificent piece of technology, named after the former NASA administrator James E. Webb, is a result of decades of planning, design, and construction. The inception of the James Webb Telescope can be traced back to the late 90s. Back then, it was just a concept, an idea that was as ambitious as it was groundbreaking. As the successor to the Hubble Space Telescope, its purpose was clear from the start: to delve deeper into the cosmos, to uncover the mysteries of the universe, and to answer the age-old question, are we alone? The anticipation around the James Webb Telescope within the scientific community has been palpable. It's not just a telescope, it's a time machine. Its powerful mirrors and sensors are designed to peer back over 13.5 billion years, giving us a glimpse into the early universe, just a few 100 million years after the Big Bang. It's also a key to unlocking the secrets of the stars and galaxies, of the formation of celestial bodies and of the exotic distant worlds that orbit them. It's a window to the past and a map to the future. It's our best bet yet to detect signs of life beyond Earth, perhaps even intelligent life. The James Webb Telescope is set to revolutionize our understanding of the universe. It's more than just a tool for observation, it's a symbol of our insatiable curiosity, of our eternal quest for knowledge. It's a testament to our capacity to dream, to innovate, and to explore the unknown. From a mere concept to a reality, the journey of the James Webb Telescope has been nothing short of remarkable. As we stand on the brink of a new era of discovery, we can only wonder, what secrets will the James Webb Telescope unveil? What new worlds will it reveal? And most importantly, will it find the answer we've all been waiting for? Only time will tell. The path to the stars is not without its hurdles. The James Webb Telescope had its fair share of challenges on its way to the launch pad. But each hurdle was an opportunity for growth, a chance to refine and improve, to ensure that the final product was not just good, but exceptional. The journey from concept to creation was a long and winding road. The telescope was first proposed in the late 90s, and it was planned to be launched by 2007. But as with many ambitious projects, it faced delays and budget overruns. The complexity of the telescope, its size, and the innovative technologies it houses all posed significant challenges. The mirror, a critical part of the telescope, was one of the biggest challenges. Composed of 18 hexagonal segments, it had to be perfectly aligned to capture the faintest light from the farthest corners of the universe. The process of testing and perfecting this alignment was painstaking and time-consuming. Then there was the sun shield, another crucial component. It had to be designed to withstand the harsh conditions of space and protect the telescope from the sun's damaging rays. The initial designs faced issues with durability and performance, leading to revisions and retests. But every setback was a stepping stone. The hurdles faced during the construction and testing of the James Webb Telescope led to improvements in its design and functionality. The mirror's alignment was perfected, the sun shield was strengthened, and other components were optimized to ensure the telescope's success in its mission. Each challenge encountered and overcome was a testament to the perseverance and ingenuity of the team behind the telescope. They navigated through the hurdles, driven by the vision of what the James Webb Telescope could do: uncover the mysteries of the universe and possibly detect signs of alien life. Despite the challenges, the James Webb Telescope made it to the launch pad, ready to embark on its cosmic journey. The hurdles it faced, far from being deterrents, were catalysts that shaped its journey to the stars. The moment had finally arrived. The James Webb Telescope was ready to take its place among the stars. As the clock counted down to zero, the world held its breath. The air was thick with anticipation, the collective heartbeat of humanity pounding in sync with the ticking seconds. It was not just a launch, it was a leap into the unknown, a bold stride towards the future of space exploration. There was a palpable sense of excitement. Scientists, engineers, and space enthusiasts across the globe had been waiting for this day, their eyes glued to screens, their hopes soaring high with the telescope. Years of painstaking work, countless hours of meticulous planning, and a shared dream to probe deeper into the cosmos were all coming to fruition at this very moment. And then, with a thunderous roar, the rocket carrying the James Webb Telescope blazed into the sky. It was a sight to behold, a testament to human ingenuity and the relentless pursuit of knowledge. The ground shook, the sky lit up, and a wave of awe swept across the spectators. The telescope was on its way, embarking on a million-mile journey to its new home in space. The launch was a success. The James Webb Telescope, a marvel of modern technology, was now in space, ready to take on its monumental task. It was set to voyage beyond the realms of known space, to places where no telescope had ever ventured before. As the telescope drifted further into the darkness of space, a sense of achievement filled the air. The James Webb was no longer a distant dream but a reality, a beacon of hope in the quest for cosmic understanding. The journey to its destination wasn't easy. It had to traverse through the harsh environment of space, battling intense heat and cold, dodging space debris, and overcoming the immense gravitational pull of the Earth. Yet, it persevered, driven by the collective will of humanity. With a successful launch, the James Webb Telescope began its mission to unravel the secrets of the universe. Imagine the moment when the James Webb Telescope sends back data indicating the presence of alien life. A moment that could redefine our understanding of the cosmos, forever altering our place in the grand tapestry of existence. Let's take a moment to ponder on this. The discovery of alien life, even if microscopic, would be nothing short of extraordinary. It would not only confirm that we are not alone in the universe, but also open up a realm of questions regarding the nature and diversity of life beyond our planet. Now let's consider the practical aspects. The initial data from the James Webb Telescope would just be the beginning. Following this groundbreaking revelation, scientists would embark on a rigorous process of verification. Multiple sources would cross-check the data, and repeated observations would be made to confirm the findings. This is a crucial step, as it is important to rule out any false positives, ensuring the integrity of such a monumental discovery. Upon confirmation, the news would send shockwaves through the scientific community and beyond. It would undoubtedly spark a new era of astrobiological research as scientists delve deeper into understanding the alien life forms. Our knowledge of biology, evolution, and ecology could be upended, and new theories and possibilities would emerge. The impact on society would be profound. Beyond the scientific implications, the discovery of alien life would also have philosophical and cultural repercussions. It would force us to reevaluate our beliefs, our ethics, and our place in the universe. The way we perceive ourselves, our planet, and our responsibilities towards it could undergo a radical transformation. The discovery of alien life would be a monumental moment for humanity, forever changing our understanding of our place in the universe. It's an exciting prospect, one that reminds us of the vastness of the cosmos and the endless possibilities it holds. Let's keep our eyes on the stars, and who knows, we might just find we have company out there. The James Webb Telescope's journey from inception to launch has been a testament to human ingenuity and perseverance. We've traveled together through its remarkable conception, its arduous journey to launch, and the thrilling possibility of discovering alien life. This journey is a reminder of what we can achieve when we reach for the stars, quite literally. As we gaze upon the stars, we might soon find out that we are not alone in the universe. Only time, and the James Webb Telescope, will tell. What if one day, out of the blue, Gliese 1214b decided to pay our solar system a visit? Imagine, if you will, a scenario where this intriguing exoplanet, nestled in the far reaches of the cosmos, suddenly makes an unexpected journey into our cosmic neighborhood. This isn't just any ordinary planet, but a water-rich super-Earth with mysteries that boggle the minds of scientists. What would happen? How would it affect our solar system? Stay with us to discover the fascinating science behind this celestial body, and what it could mean for us all. First things first, it's time to get to know our unexpected visitor, Gliese 1214b. Gliese 1214b, a fascinating exoplanet, is an intriguing entity in the cosmic landscape. But before we delve into its specifics, let's clarify what an exoplanet is. Simply put, an exoplanet is a planet that orbits a star outside of our solar system. Imagine our Earth, but in a different solar neighborhood, so to speak. Now back to Gliese 1214b. Located approximately 40 light-years away from us in the constellation Ophiuchus, this celestial body is about 2.7 times the size of Earth. It's a super-Earth, a class of planets that are larger than Earth but smaller than gas giants like Jupiter or Saturn. But size isn't the only thing that makes Gliese 1214b remarkable, it's its composition that truly sets it apart. Unlike anything we have in our solar system, Gliese 1214b is believed to be a water world. Picture an ocean planet where water doesn't just cover the surface but extends down to depths we can hardly fathom, potentially creating exotic forms of ice under extreme pressure. It's not just a water world, but it's also shrouded in a thick, steamy atmosphere, making it a hot and humid world with temperatures soaring up to 500 degrees Fahrenheit. This makes it inhospitable for life as we know it. But its unique features don't stop there. Gliese 1214b orbits its star at a remarkably close distance, much closer than Mercury is to our Sun. This results in a year on Gliese 1214b lasting a mere 38 hours. Now that we're familiar with Gliese 1214b, let's dive into what might happen if it entered our solar system. Imagine waking up to the news that Gliese 1214b has entered our solar system. What would that mean for us? Let's delve into this. The first thing we'd notice would be the gravitational shifts. Gliese 1214b is roughly 6.5 times the size of Earth. That's a substantial mass entering our cosmic neighborhood. Its gravitational pull would be significant, to say the least. It could potentially disrupt the delicate gravitational balance that keeps our solar system in order, causing shifts in the orbits of planets, asteroids, and comets alike. For instance, our moon, held in place by Earth's gravity, might feel the lure of this new celestial body. If the moon's orbit were to change, we'd see dramatic shifts in our tides. Coastal cities might find themselves underwater, while others could become barren wastelands. The stability of Earth's tilt, responsible for our seasons, could also be affected, leading to unpredictable weather patterns and climate change on a global scale. Planets further out in the solar system wouldn't be immune to these changes either. The orbits of outer planets like Jupiter and Saturn could be altered, affecting the gravitational harmony that's been in place for billions of years. The asteroid belt too could be disturbed, sending asteroids on new paths, some potentially towards Earth. But it's not all doom and gloom. The arrival of Gliese 1214b would also present some fantastic opportunities for scientific discovery. We'd have a chance to study an exoplanet up close, without the need for long-distance telescopes or interstellar travel. We could learn about its atmosphere, its composition, and maybe even find signs of life. This could revolutionize our understanding of the universe and our place within it. So, while the arrival of Gliese 1214b in our solar system would indeed bring challenges, it could also herald an era of unprecedented scientific exploration and discovery. The effects would be far-reaching and dramatic, but let's not forget the opportunities this situation might present. Every cloud, or in this case, exoplanet, has a silver lining. And when we're talking about Gliese 1214b, that silver lining takes the form of a treasure trove of scientific opportunities. Imagine, an exoplanet previously light years away, now within our solar system's reach. The wealth of information that Gliese 1214b could provide is almost unimaginable. We're talking about the potential to revolutionize our understanding of the cosmos. Let's start with the planet's atmosphere. With Gliese 1214b in our solar system, we could study its atmospheric composition in ways we've never been able to before, not just through distant telescopes but up close and personal. This could provide invaluable insights into what makes an exoplanet's atmosphere tick, and how it interacts with its star and the space around it. But the opportunities don't stop there. Gliese 1214b's unique composition, believed to be a mix of water and high-pressure ices, could shed new light on the diverse range of planets found throughout the universe. It's a chance to delve deeper into the mysteries of planet formation and evolution. And let's not forget the potential to gain insights on the existence of life beyond Earth. If we can study Gliese 1214b's environment in depth, we might just find clues about the conditions necessary for life to thrive on other planets. In essence, Gliese 1214b could be our cosmic Rosetta Stone. It could unlock the secrets of the exoplanets and help us understand our place in the grand scheme of the universe. We're not saying the journey will be easy, nor are we underestimating the challenges that such a cosmic event would bring. But as with all great scientific endeavors, the rewards could be monumental. The arrival of Gliese 1214b could unlock a universe of knowledge. So as we contemplate the what-ifs of this cosmic scenario, let's remember the silver lining. The potential to learn, to discover, and to deepen our understanding of the universe we call home. We've taken a fascinating journey today, exploring the what-ifs of a cosmic event. We've delved deep into the characteristics of Gliese 1214b, an exoplanet intriguing in its own right. With its enormous size and water-rich atmosphere, this celestial body is unlike any planet in our familiar solar system. We've also pondered the potential impact of Gliese 1214b's arrival into our solar system. Its presence could disrupt the delicate gravitational balance we've come to understand and rely upon. Yet such an event is not all doom and gloom. It could also provide us with an unprecedented opportunity to study an exoplanet up close, to understand its structure, its atmosphere, and perhaps even its potential to harbor life. We've imagined the silver linings that could come with such a cosmic event. The potential for scientific discovery and advancement is immense, opening doors to new fields of research and understanding. Our cosmic journey today has been a testament to the power of scientific inquiry and the boundless curiosity of the human mind. It's a reminder that our universe, in all its vastness and complexity, is ripe with opportunities for exploration and discovery. While the arrival of Gliese 1214b remains a hypothetical scenario, it's a reminder of the incredible universe we're a part of and the endless possibilities it holds. As we conclude our cosmic journey, let's ponder on one last thought. Our universe is an enigma, a colossal cosmic puzzle that extends far beyond our small blue planet. Each star we see in the night sky could be a sun to another world, like Gliese 1214b. Each of these worlds is a testament to the boundless possibilities that our universe holds. They remind us of our humble place in this grand cosmic theater and our relentless pursuit to understand it. Space exploration is not just about rocket ships and astronauts. It's an endeavor that pushes the boundaries of our knowledge, that challenges our understanding of the universe and our place within it. It's about seeking answers to questions we haven't even thought to ask yet. What if Gliese 1214b came to our solar system? What would it tell us about our own planet, about the formation of planets, or about the possibility of life beyond Earth? These hypothetical scenarios are more than just food for thought. They serve as powerful catalysts that spark our curiosity, that drive us to probe deeper into the mysteries of the cosmos. They inspire us to invest in scientific discovery, to create technology that can reach beyond our own world, and to imagine realities beyond our current comprehension. As we stand on the brink of a new era of space exploration, we must remember that every discovery, every new piece of the cosmic puzzle, brings us one step closer to understanding our place in the universe. It's a journey that will necessitate courage, curiosity, and an unquenchable thirst for knowledge. So, as we bid farewell to Gliese 1214b, let's carry this curiosity with us. Let's keep asking questions, keep seeking answers, and keep pushing the boundaries of what we know. Remember, every star in the sky holds a story waiting to be told. Until next time, keep exploring, keep questioning, and keep looking up. Goodbye. Imagine a nuclear explosion on Mars, a statement that might seem pulled straight from the pages of a science fiction novel. Yet this idea has been proposed and discussed in the realm of scientific possibility, most notably by SpaceX founder Elon Musk. But why consider such a drastic measure? The answer lies in an ambitious goal known as terraforming. Terraforming, for those unfamiliar with the term, refers to the theoretical process of modifying another planet's environment to make it Earth-like, thus suitable for human habitation. Mars, being our closest neighbor, has always been a prime candidate for this process. Elon Musk's plan involves using nuclear explosions to vaporize the Martian polar ice caps. This would release carbon dioxide trapped within the ice into the atmosphere, creating a greenhouse effect. The temperature on Mars would gradually rise, potentially making the planet more hospitable for human life. This is not an idea born of whimsy or an apocalyptic vision of the future, but rather a potential solution to the existential threat facing humanity, the depletion of resources and overpopulation on Earth. Now, it's important to remember that this is a highly controversial proposal. There are numerous scientific, ethical, and logistical challenges to consider. For instance, could we control the nuclear fallout? Would the released carbon dioxide create a sustainable atmosphere? Or would it merely lead to a temporary spike in temperature? And what about the potential for life already existing on Mars? Could a nuclear explosion wipe out any chance of discovering Martian life? Moreover, the idea of detonating nuclear weapons on a neighboring planet raises significant legal and political questions. The Outer Space Treaty of 1967, which prohibits the use of nuclear weapons in space, is a key obstacle. Now, having a nuclear explosion on a planet isn't a small event. Let's delve into what this could entail. The next scenes will explore the immediate impact, long-term consequences, the potential for life on Mars, and possible alternatives to this nuclear conundrum. A nuclear explosion is no child's play. It has far-reaching consequences. Let's imagine for a moment the immediate aftermath of such an event on Mars. The first thing that would happen is the creation of an artificial sun. This is because the sheer amount of energy released in a nuclear explosion is so immense, it can actually create a ball of plasma that glows as brightly as our own sun. Now, this artificial sun would not last very long. However, during its brief existence, it would release an enormous amount of heat and radiation, which would have a dramatic effect on the Martian environment. The heat would cause the polar ice caps to melt, releasing vast quantities of water vapor into the atmosphere. The radiation, on the other hand, would ionize the gases in the Martian atmosphere, creating a powerful electromagnetic pulse, or EMP. This EMP could potentially interfere with any electronic equipment on the Martian surface, including any rovers or landers we might have sent there. But the effects of a nuclear explosion on Mars would not be limited to the atmosphere. There would also be seismic activity to consider. The force of the explosion would send shock waves through the planet's crust, causing earthquakes and possibly even volcanic activity. This seismic activity could potentially reshape the Martian landscape, creating new mountains, valleys, and other geological features. And then there's the matter of fallout. The radioactive debris from the explosion would be carried by the Martian winds, spreading radiation across the planet. This fallout could potentially contaminate any future landing sites, posing a significant risk to future Mars missions. In short, the immediate impact of a nuclear explosion on Mars would be catastrophic. It would drastically alter the planet's environment and geology, and potentially pose a significant risk to any future human missions. But the immediate impact is just the beginning. What about the long-term effects? After the dust settles, what's left? The aftermath of a nuclear explosion on Mars would indeed be a spectacle to behold, but it's the long-term consequences that truly deserve our attention. The detonation's colossal energy could potentially kickstart a change in the Martian climate. Now, we're not talking about a light drizzle or a sunny day, but rather a shift in atmospheric conditions that could make Mars more Earth-like. The nuclear explosion would set off a chain reaction, melting the planet's icy poles and releasing carbon dioxide, a potent greenhouse gas. This could induce a greenhouse effect, trapping the sun's heat and making Mars warmer. But it's not all about turning up the heat. Increasing the temperature might also help to thicken the thin Martian atmosphere, making it more suitable for humans. Imagine stepping out onto the surface of Mars, not in a bulky spacesuit, but in your favorite jeans and t-shirt. It might sound like science fiction, but this could be the key to making Mars our second home. However, as they say, with great power comes great responsibility, and nuking Mars is no exception. The nuclear fallout could pose considerable risks to future human colonies. The residual radiation, for instance, could linger for thousands of years, creating a hazardous environment for any potential settlers. Not to mention, the fallout could also contaminate Mars's resources like water and soil, making them unsuitable for consumption or farming. Moreover, the explosion might also destabilize the Martian surface, triggering earthquakes or Marsquakes, as we like to call them. These seismic activities could cause landslides, creating an unpredictable and dangerous landscape for future explorers. So while the idea of nuking Mars might seem like a quick fix to making the planet more habitable, the long-term consequences could be far-reaching and potentially harmful. As we venture into the realm of interplanetary colonization, we must tread carefully and consider the lasting effects of our actions. These long-term effects could drastically alter the red planet. But what about life on Mars? Could a nuclear explosion wipe out Martian life? A question that might sound like science fiction. But today it's a very real consideration. Let's delve into the potential impact of a nuclear explosion on any existing or future life on Mars. Imagine for a moment the red, dusty landscape of Mars. A place where we've long speculated about the existence of life. From microscopic organisms to the possibility of ancient civilizations. Now imagine that landscape subjected to a nuclear explosion. The radiation unleashed would be cataclysmic, with the potential to obliterate any life forms that may exist or could potentially exist in the future. Radiation, as we know, is a powerful and destructive force. It can break down the fundamental building blocks of life, DNA. Any organisms that manage to survive the initial blast would be subjected to the long-term effects of radiation exposure, which could lead to mutations and, inevitably, death. However, it's not just about the life that might currently exist on Mars. We also have to consider the future. Humankind has long dreamed of one day colonizing Mars, but a nuclear explosion could make this dream impossible. The radiation would render the planet uninhabitable for us, making the prospect of a Martian colony nothing more than a pipe dream. Moreover, the search for life on Mars is not just about finding organisms that are currently living. It's also about searching for signs of past life, learning about the planet's history and understanding if Mars could have once harbored life. A nuclear explosion could destroy these historical traces, erasing millions if not billions of years of Martian history. So, as we contemplate the idea of nuking Mars, we must consider the potential consequences. Not just for us, but for the planet itself and any life that may exist there, now or in the future. A nuclear explosion could potentially end any chance of finding life on Mars, but is there an alternative? As we move forward, we must consider this question carefully, weighing the potential benefits against the undeniable risks. The future of Mars, and potentially the future of humankind, hangs in the balance. Nuking Mars might not be the best idea, so what are the alternatives? Well, there are several ways we can approach this. One alternative is the slow process of terraforming. Rather than violently reshaping Mars with nuclear explosions, we could gradually alter its climate over hundreds or even thousands of years. This would involve a variety of methods, from introducing greenhouse gases to increase the planet's temperature, to building giant mirrors in space to reflect sunlight onto the Martian surface. But terraforming isn't our only option. Another intriguing possibility is the use of bioengineered organisms. Scientists are exploring how we might design life forms to survive in Mars's harsh environment and slowly transform it into something more Earth-like. These organisms could produce oxygen, break down the Martian soil into fertile ground, or even help create a magnetosphere to protect the planet from solar radiation. As we consider these alternatives, it's important to remember that Mars isn't just a blank canvas for us to paint on. It's a world with its own history, its own geology, and potentially its own life. We have a responsibility to treat it with respect. This leads us to the future of Mars exploration. The next few decades will likely see a flurry of missions, both robotic and human, to the Red Planet. These endeavors will help us learn more about Mars, its potential for life, and how we might one day live there ourselves. But as we push forward, we should always keep in mind the ethical considerations of altering another planet. Should we change Mars to suit us? Or should we change ourselves to suit Mars? It's a question without easy answers. But as we continue our journey into the cosmos, it's one that we'll have to grapple with. As we continue to explore the cosmos, these are the questions we must ask ourselves. What do you think would happen if we nuked Mars? Have you ever thought about the sun as a massive nuclear furnace ceaselessly burning? That's right. Our sun, that familiar celestial body we see every day, is essentially a gigantic nuclear reactor, continuously undergoing a process called nuclear fusion. This is not your average fire, my friends. This is nuclear fusion, a process by which hydrogen atoms, under tremendous heat and pressure, combine to form helium atoms. But here's the kicker. This process doesn't just produce helium, it also releases a colossal amount of energy. This energy, in the form of light and heat, streams out from the sun, traverses the 93 million miles of space to reach our little blue planet we call Earth. And what would we be without this energy? Well, life as we know it wouldn't exist. You see, the sun's energy is the primary source of heat for our planet. It's what powers the water cycle, driving the rains and winds that shape our landscapes. It's what fuels photosynthesis, the process by which plants convert sunlight into chemical energy, providing the basis for virtually all life on Earth. But that's not all. The energy from the sun doesn't just stop at making life possible. It also provides us with renewable sources of energy, from solar panels soaking up the sun's rays to generate electricity, to wind turbines spinning in the breeze created by the sun's uneven heating of the Earth's surface. We are harnessing the sun's energy in a myriad of ways. So let's take a moment to appreciate this massive, blazing ball of gas. The sun, our sun, is more than just a bright light in the sky. It's an everlasting nuclear furnace, a powerhouse of energy that keeps our world turning. It's the lifeblood of our planet, a celestial dynamo that has been burning for about 4.5 billion years and will continue to burn for another 5 billion or so. In essence, the sun is a natural, self-sustaining nuclear reactor. Now, imagine humanity's most destructive invention, the nuclear weapon. Born out of the need for an upper hand in the theater of war, nuclear weapons have come to symbolize the devastating power humanity can wield. At the heart of these weapons is a process known as nuclear fission. Picture, if you will, a heavy atom like uranium or plutonium. When struck by a neutron, these atoms split into smaller atoms. This splitting or fission of atoms releases a tremendous amount of energy, enough to level entire cities. This process is not unlike the one taking place in the sun, where atoms combine or fuse together to release energy. However, instead of fusing atoms together like the sun, nuclear weapons split them apart. And the energy released? It's on a scale similar to the sun, but channeled in a devastatingly destructive manner. The world witnessed the destructive power of nuclear weapons in the summer of 1945. The cities of Hiroshima and Nagasaki in Japan were subject to this destructive force, resulting in the loss of hundreds of thousands of lives. The aftermath was equally horrifying. Those who survived the initial impact suffered from radiation sickness, burns, and the mental trauma of having witnessed such a calamity. Such is the power of nuclear weapons, a power that humanity wields with a heavy responsibility. These weapons are not just symbols of military might, but also reminders of the devastation they can cause. They serve as a testament to human ingenuity, a perverse example of our ability to harness the fundamental forces of nature, not for creation, but for destruction. Nuclear weapons, therefore, are man-made devices capable of releasing energy on a scale similar to the sun, but in a destructive manner. The sun gives life, while nuclear weapons, when used, bring only death and destruction. The contrast couldn't be starker. As we continue our exploration of what would happen if we were to nuke the sun, let's keep this in mind. What would happen if we were to launch a nuclear weapon into the sun? Ah, the realm of hypotheticals, a place where our curiosity runs wild. Let's explore this scenario, shall we? In theory, if we were to somehow manage to hurl a nuclear weapon into the sun, what would happen? Well, first things first, we need to understand the nature of the sun itself. It's not a solid ball of rock like Earth, rather, it's a giant glowing ball of hot plasma, with temperatures reaching millions of degrees at its core. That's hotter than any nuclear bomb we've ever created. Now imagine our nuclear weapon blazing through the cosmos, on a collision course with this fiery celestial body. As our nuclear missile draws closer, it is greeted by an increasingly hostile environment. The sun's intense heat starts to take its toll, and the weapon begins to vaporize long before it ever reaches the sun's core. The metals, the electronics, the nuclear material itself, everything would be reduced to its basic atomic components. But let's say, against all odds, our nuclear weapon somehow survives the journey and reaches the sun's core. What then? Well, the sun is essentially a natural nuclear reactor, constantly undergoing nuclear fusion. This process is millions of times more powerful than any nuclear weapon we can produce. So even if our nuclear bomb were to detonate at the sun's core, it would be like throwing a pebble into the ocean. The sun wouldn't even notice. So after all the effort, all the resources spent, and all the risks taken, the end result would be a whole lot of nothing. Our nuclear weapon, once a symbol of humanity's destructive power, would be reduced to a mere puff of plasma, swallowed up by the sun's immense energy. Hence, it's safe to say that nuking the sun would be a futile endeavor. It's an interesting thought experiment, but in reality it's a mission with no real reward, and a whole lot of potential risks. But let's delve deeper into the aftermath of such a scenario. The first thing to consider is that our hypothetical nuclear bomb, however powerful, would likely be dwarfed by the sun's own immense energy. This doesn't mean, however, that it would go unnoticed. The energy released by the bomb could potentially trigger a solar flare or a coronal mass ejection. What are these, you ask? Well, they're basically huge eruptions of energy on the sun's surface, and they can have significant effects right here on Earth. Solar flares and coronal mass ejections can send a wave of charged particles hurtling towards Earth. When these particles interact with our planet's magnetic field, they can cause geomagnetic storms. These storms can have a range of effects, from creating beautiful auroras to potentially disrupting electronic systems. If a particularly strong storm were to hit Earth, it could knock out power grids, disrupt satellite communications, and even affect the navigation systems on which we all so heavily rely. But this isn't just about the physical consequences. There are also ethical implications to consider. The sun, after all, isn't just our own private energy source, it belongs to all the life forms in our solar system. Taking such a drastic action could have unforeseen consequences not just for us, but for any potential life elsewhere in the solar system. And let's not forget the psychological impact. The knowledge that we had tried to nuke the sun, that we had attempted to tamper with the very source of our life-giving energy, could have a profound effect on the human psyche. It could make us question our place in the universe, our responsibility as a species, and our ability to control our own destructive impulses. So while our hypothetical bomb might not blow up the sun, it could still have far-reaching consequences. It could disrupt our technology, challenge our ethics, and shake our understanding of ourselves. While the sun would remain largely unaffected, the consequences on Earth could be far-reaching. So what does this exercise in speculative science teach us? Firstly, it underscores the scale of the sun's nuclear reactions, a scale far beyond human capabilities. The sun, a seemingly endless nuclear furnace, operates on a level of power that dwarfs our deadliest creations. It churns out energy at a rate equivalent to 1 billion megaton nuclear bombs every second. That's 1 billion times the strength of the largest nuclear weapon ever detonated on Earth, every single second. This thought experiment also highlights the limitations of our power. Despite the destruction we can wreak on our own planet, in the wider cosmos, we are insignificant. The sun wouldn't even notice if we hurled our entire nuclear arsenal into its fiery maw. Instead, it would continue to burn, unabated and unbothered, providing light and life to our world as it has for billions of years. But perhaps the most important lesson to draw from this is the importance of humility. We humans have a tendency to overestimate our importance in the grand scheme of things. We build towering skyscrapers, split atoms, and even leave our footprints on the moon. Yet, when faced with the colossal forces of nature, we are but a speck in the cosmic sea. This realization should not discourage us but rather inspire respect and responsibility. We are the caretakers of Earth, our only home. We wield the power to both create and destroy, and with this power comes immense responsibility. We must use our scientific knowledge wisely, not to wage wars or wreak havoc, but to better understand our place in the cosmos, to protect our planet, and to ensure the survival and prosperity of future generations. In the grand scheme of the universe, our most destructive weapons are but a speck of dust before the immense power of the sun. And that, my friends, is a lesson in humility. Have you ever wondered how advanced a civilization can get in the infinite expanse of the universe? The potential is staggering. Are we alone in this cosmic dance, or are there others out there in distant galaxies far more advanced than us? The universe is a vast playground, ripe with potential. Civilizations, ours included, could develop in unimaginable ways, harnessing the power of stars, galaxies, and perhaps even the universe itself. You see, there's a fascinating concept that provides a roadmap for this kind of development. It's called the Kardashev scale. Named after the Russian astrophysicist Nikolai Kardashev, this scale is a method of measuring a civilization's level of technological advancement based on the energy it is able to use, but we're just scratching the surface here. The Kardashev scale, a method of measuring a civilization's level of technological advancement, could be the key to understanding this. Russian astrophysicist Nikolai Kardashev proposed a scale of technological advancement that has since become a staple in the discussion of extraterrestrial life. This scale, known as the Kardashev scale, is a method for measuring a civilization's level of technological advancement based on the amount of energy they are able to utilize. To start off with, we have Type 1 civilizations. These societies have managed to harness all the energy available on their home planet. Imagine a world where every drop of sunlight, every gust of wind, every rumble of the Earth's core is captured and utilized. The entire planet becomes a buzzing hub of energy production and consumption. Then we advance to Type 2 civilizations. These are societies that have gone beyond their home planet and now draw energy directly from their parent star. Picture a colossal structure, known as a Dyson sphere, encapsulating the sun and absorbing the majority of its energy output. It's a level of technological prowess that makes our current efforts seem like child's play. Finally, we reach the pinnacle of the Kardashev scale as we know it. Type 3 civilizations. These are societies that have become galactic, harnessing the energy of entire star systems, even galaxies. Imagine a civilization that has spread across the stars, where traveling light years is as commonplace as your daily commute. Each level on the Kardashev scale represents a quantum leap in technological progression, a monumental shift in how a civilization interacts with the universe around it. But it's not just about energy consumption. Each level also implies a certain level of societal advancement, of unity, and cooperation on a scale we can barely comprehend. However, the Kardashev scale is not an absolute measure. It's a framework, a roadmap of possibilities. And like all maps, it has its edges, its frontiers. But what if we told you that this scale doesn't stop there? Yes, there's more to civilization advancement than what the classic Kardashev scale proposes. Let's journey beyond the confines of this cosmic scale and into the realm of the unimaginable. Picture a civilization that has transcended the boundaries of its galaxy, harnessing energy on a scale far beyond our comprehension. This, my friends, is what we call a Type 4 civilization. Type 4 civilizations are those that have mastered the power of their entire galaxy. Imagine the ability to manipulate and control the energy of billions of stars, black holes, and nebulae. The possibility of their existence challenges our understanding of the universe and our place within it. But why stop there? Let's take another leap into the cosmic unknown. What if a civilization could harness the energy of the entire universe? This is the realm of a Type 5 civilization. From the faintest star in the most distant galaxy to the energy of the Big Bang itself, A Type 5 civilization would command an unimaginable level of power and knowledge. These theoretical possibilities are mind-boggling, aren't they? And yet, they serve as a testament to the potential of civilizations, to the heights that we, as a species, could potentially reach. However, it's important to remember that these are mere speculations. Our understanding of the universe is still in its infancy. The existence of Type 4 and V civilizations is purely hypothetical based on our current understanding of energy and how it can be harnessed. Yet, these hypotheses serve a purpose. They push us to question, to explore, to imagine. They urge us to dream about the future, to envision a time when we might leapfrog from our current Type 0 status to become masters of our planet, our star, our galaxy, and perhaps even our universe. Such civilizations would seem almost godlike to us, wouldn't they? But even gods can have limits. The Kardashev scale, while fascinating, is not without its limitations and criticisms. Let's delve deeper into some of these. One of the main criticisms of the Kardashev scale is its focus on energy consumption. The scale assumes that the more advanced a civilization is, the more energy it consumes. However, this viewpoint can be challenged. It is entirely possible for a civilization to become more advanced by becoming more efficient, rather than by simply consuming more energy. Consider this. Imagine a civilization that has mastered quantum computing and has developed technology that can manipulate matter at the atomic level. Such a civilization might be able to achieve incredible feats with relatively low energy usage. In this scenario, the Kardashev scale would not accurately reflect the level of advancement of this civilization. Another limitation of the Kardashev scale is the assumption that civilizations will want to expand indefinitely. This is based on our current understanding and our own human drive to explore and colonize. However, it is conceivable that an advanced civilization might choose a different path. Perhaps they've developed a deep respect for the cosmos and choose to live in harmony with it, rather than colonizing it. Or maybe they've transcended physical existence entirely, living in a digital realm of their own creation. Again, the Kardashev scale would fall short in these cases as it is based on physical expansion and energy consumption. Lastly, the Kardashev scale in its current form doesn't account for the diversity of life that could exist in the universe. Life as we know it is carbon-based and requires certain conditions to thrive. But who's to say that life couldn't exist in forms we haven't even imagined yet? Life that doesn't need massive amounts of energy or expansive territories to flourish. These are just a few of the limitations and criticisms of the Kardashev scale. As our understanding of the universe broadens, it's likely that our measures of advancement will need to evolve as well. As we venture further into the cosmos, we might need to rethink our measures of advancement and success. Imagine a future where humanity has evolved into a Type 1, 2, or even the 3 civilization. What would that look like? Let's dive into the realm of possibilities, shall we? Harnessing the power of an entire planet, that's a Type 1 civilization for you. The Earth as we know it would transform into a colossal energy generator. We'd have to master technologies to control natural disasters, manipulate the weather, and even tap into the core of our planet for energy. The challenges? Well, they're immense. We'd need unprecedented global cooperation, technological breakthroughs, and a profound respect for our planet to maintain its health while we extract its energy. Now, let's take a leap and envision a Type 2 civilization. Harnessing the power of a star, our sun in this case, would be the name of the game. Imagine a structure, a megastructure encapsulating the sun and absorbing its energy. We'd be talking about technologies that can withstand the immense heat and radiation of a star. The challenges? They're astronomical, literally. We would need to overcome extraordinary engineering hurdles and manage the enormous amounts of energy without causing catastrophic damage. Finally, a Type 3 civilization, the pinnacle of the Kardashev scale. Here we're dealing with a civilization that has harnessed the energy of an entire galaxy. This would require mastering interstellar travel, colonizing countless planets, and manipulating stars and black holes for energy. The challenges are beyond comprehension, extending to the very fabric of space and time. But what if we succeed? What if we overcome these hurdles and continue to evolve? The possibilities are as limitless as the universe itself. We could explore the cosmos, unravel the mysteries of the universe, and even encounter other civilizations. The future of civilizations, ours and potentially others, is a fascinating topic. It invites us to dream, to innovate, and to strive for progress. It also reminds us of our responsibility to our planet and to each other, as we navigate the path towards becoming an advanced civilization. The universe is vast and mysterious, filled with endless possibilities, and maybe, just maybe, we might get to see some of them in our lifetime. So, we've journeyed through the Kardashev scale and even beyond it. We've traversed the vast expanse of the universe, exploring the energy-harnessing potential of civilizations. We've understood the Kardashev scale, a measure of a civilization's technological advancement based on its energy consumption. We've delved into the idea of civilizations beyond the scale, those that might harness energy from black holes, or even manipulate spacetime itself. We've pondered on the limitations of the Kardashev scale, realizing that it might not encapsulate the full potential of advanced civilizations. We've envisioned the future of civilizations, how they might evolve and grow, transcending our current understanding of technology and energy utilization. We've touched upon the potential of civilizations to become intergalactic, perhaps even multidimensional. In the grand scheme of the universe, we have much to learn and even more to discover, but isn't that the most exciting part?